What is up, guys? My name is Andrew, and I'm the host of Food with Friends. We've been learning about the story of Michael, who grew up in the Bronx, ended up in Silicon Valley, started his own company in his garage, and also did work for Amazon. Now, we're going to dive into quantum computing, the past, present, and future, which is an area that Michael has some crazy expertise on. I hope you enjoy the video. Where do you see the future of quantum computing going?
It's going to be a niche problem solver, but fortunately, some of the niches it can solve are classical computers can't do it all. So the first killer app is cryptography. So most of the cryptography people have been using for the last 30 years will be easily crackable once a quantum computer of say a couple hundred bits comes online. And so you have to imagine that governments have been saving up encrypted messages from other governments and individuals for decades now.
And when that day comes,
right.
That's gonna talk. We see stuff in the news now. Everything's gonna kind of blow up when people, I think, start decrypting other people's, messages over the years. Hey, you said this. You leaked this to this person, and this went to that person.
Right.
Oh my gosh.
Yeah, one of my friends, he was planning to build a quantum computer, and he got funding from the NSA with the condition that whatever he built in his lab at the university, he had to duplicate at the NSA.
Wow.
Right.
So everyone's chomping at the bit to try and get a quantum computer.
Largely the government for cracking code. Very fortunately, the other big app is in modeling molecular interactions and atomic interactions. And the idea there is that right now, about a third of the world's supercomputer power is spent modeling molecular and atomic interactions.
Okay.
And this is for drug design, de novo drug design, and also new materials, figuring out what the properties
things that can help further and benefit society.
Right, right, and industry. So that's what a third of the world's supercomputer power is spent doing. Probably some other large fraction is spent trying to crack code. But right now they're basically trying to solve Schrödinger's equation, a quantum equation, using Newton's equations, classical equations. Okay. And so that's in part why it's so difficult, because classical physics and quantum physics are qualitatively different. So a hand-waving explanation is that, well, if you have a quantum computer, you're basically using Schrödinger's equation to solve Schrödinger's equation. You're already using a quantum device to solve a quantum problem, and it's just much faster.
It translates across.
Right, right. But that's just an arm-waving explanation. But so quantum computers will be much faster for solving small molecule and atomic interactions that way. So they'll have a big impact in new drug development and new materials development. So that'll probably replace the supercomputers that are being used right now.
Wow.
And most people think it'll take a long time before quantum computers are that powerful. But some companies are making very good progress, such that there'll probably be a quantum computer that can solve a computer problem that a classical computer cannot solve quickly, but a quantum computer can, probably within the next 5 years.
Okay.
There'll be a quantum computer available that's more powerful than a classical computer.
Okay, so it's a lot closer than people are making it out to be.
Yeah, yeah. But again, there's a lot of hype in the field.
Yeah.
Like an unbelievable amount of hype. So people were claiming all kinds of ridiculous things, like they already had a 100-bit quantum computer and they'd already solved problems that no classical computer solved, and those all turned out to be false. So there's a lot of suspicion and caution among venture capitalists and the press and the public now about claims having to. Yeah. So I've always been fascinated. I've been fascinated by quantum mechanics ever since I first understood what it was about. Like at Berkeley, I would go to my quantum professor and I'd ask him a question. He'd give me an answer. And then I'd go to another professor and ask him the same question. He'd give me a completely different answer. So it seemed like nobody really understood quantum mechanics.
Hmm.
And in fact, Richard Feynman has said famously, no one really understands quantum mechanics. So that fascinated me. So over the past 2 years, I've been trying to understand quantum mechanics.
Yeah.
So I've managed to make a little bit of progress, and I've published a few papers,
Hmm.
and I'm working on another paper now. But that's what I've been doing for the past 2 years, is working on quantum foundations. It's called the Foundations of Quantum Mechanics.
Okay,
And
so
trying to solve problems like Schrodinger's cat problem.
got it, which will kind of help people as they move forward with building the quantum computers to have a
In the long range, yeah. My belief is that we're held back in developing quantum technologies because we still haven't solved the problems that came up in the 20s when people first developed quantum physics. There were unsolved paradoxes, quantum paradoxes, and no one could solve them, like the Einstein-Podolsky-Rosen paradox. No one could solve them, and they were just sort of swept onto the rug at the time.
Is it because people just wanted to keep moving forward and they're like, oh, okay, we'll get around to this? I mean, sounds like a core fundamental piece.
Yeah, so Niels Bohr and his friends, they believed that they had solved quantum mechanics completely,
Mm-hmm.
and it was a done deal. And so they actually blacklisted physicists who would work on alternative explanations outside of the Copenhagen formulation. So the Copenhagen interpretation was considered the Bible of quantum physics, and it had been developed by Niels Bohr, Heisenberg, and their friends. And there were people who thought it was wrong or incomplete, like Einstein and Schrodinger. And
some big names, not just everyday guys.
Yeah. But Bohr was very powerful in the physics world and in academia. And so he was able to actually suppress the development of other schools of thought about quantum interpretations. In fact, one of my mentors, he did the first experiment demonstrating quantum entanglement, which is a big thing. He basically, John Stuart Bell came up with Bell's theorem back in the 60s. And it's sort of a famous theorem. Some people consider it the most important theorem in physics. And the idea is that nature is non-local, that something that happens here can affect something that happens on the other side of this solar system instantaneously. In experiment.
Yeah.
And so so John Clauser, one of my mentors, he did an experiment at Berkeley that showed that Bell was correct, that things did have instantaneous action at a distance, according to the Copenhagen interpretation. He did this as a postdoc, and he was never able to get a faculty position anywhere. And it's believed that that's because he basically, that was a strike against the Copenhagen formula.
And so everyone just shut him down.
Yeah. So in fact, Bell's original paper basically sat in the press unmentioned for over a decade. There were maybe just one or two references to it before John Clauser actually picked it up and tried doing an experiment based on his paper.
Oh my gosh.
So Bohr and his friends and the quantum community at the time were very successful in shutting down alternative interpretations. Even still. Until, and I mean, I think that's why quantum computing took so long to develop, is because it was considered a philosophical question, not a scientific question. And so people didn't work on it. It was considered taboo to work on. And if you started working on it earlier in your career, you probably wouldn't get tenure. And now that's changed since the development of quantum computing. So, but quantum computing, I think, was delayed by decades because of the Niels Bohr and the other thing that physicists came up with was the motto became "shut up and calculate" with quantum mechanics. The idea being that quantum mechanics, by manipulating the equations and applying it to different problems, we were getting lots of really exciting, good results out, experimental results and theoretical results. We should forget about the philosophy part, since that's merely philosophy, and we should concentrate on turning the crank on the equations and making predictions. And so everybody called it "shut up and calculate." Don't talk about what it means. Don't think about what it means.
Just run the numbers.
Run the numbers. Yeah. And physics has been shut up and calculate. It was shut up and calculate while I was at grad school at Berkeley
Yeah.
with the professors because of things that happened in the 20s.
But
And
it's finally starting to change.
it's changing now. Well, so there's this saying that physics theories never die, but physicists eventually die. And that's how theories change.
Yeah.
So most of the old guard, the original physicists, are all dead and gone. And their mentees are also dead and gone now in most cases. So it's really a third generation removed that is working on quantum foundations.
But their theories are still around, though.
Yeah, the theories are still in the textbooks.
Mhm.
So all the textbooks are based on the Copenhagen interpretation.
Mhm.
So you have to learn that. But people have been attacking the Copenhagen interpretation in publications, and people have been writing books about how there's problems with it and it's wrong in these ways. And that's partly what I've been doing as well.
Yeah.
So people are openly rebelling against the Copenhagen interpretation now. And since they have results, they have experimental results in quantum cryptography and quantum computing, they can get tenure, right? I mean, if they were just rebelling with no experimental proof, they might still be blackballed.
But now they've got proof, and so
right.
it's like, all right, yeah, you can come on in.
Yeah. So
that's exciting, though, because that sounds like, from what you said, that's going to propel the speed that people have full, 100-bit plus quantum computers built. That's going to propel the speed like crazy.
Right. Now I should preface this with a warning that this is all my personal opinion.
Yeah.
Of how history happened and why various other things happened. So it's my personal opinion. It's not something many physicists would disagree with me that's what happened. In fact, there's still a lot of Copenhagen physicists around who basically, if you start asking them questions about Copenhagen, they will give you a few answers. But then if you probe deeper, they will refuse to answer any further questions.
Wow.
Yes. So it's in my mind, it's a project for psychiatrists to figure out. It's nothing to do with physics.
Yeah. Okay, so you've been working on that for the past 2 years.
Yeah. So that's what I've been doing, and I've been enjoying it a lot. It's been really worthwhile, and I've also learned a lot more about quantum physics than I knew. But we still have to save up enough money to retire.
Yeah.
So I am now applying for jobs back in industry again.
Yeah.
So I am interviewing and looking for interesting work in industry that hopefully helps mitigate climate change, because climate change seems to be the biggest problem facing humanity.